In this tutorial, we will be discussing esters. Esters are synthesized from the reaction of carboxylic acids and alcohols found in fats and oils and are responsible for the aroma and flavor of bananas, oranges, and strawberries. If we look at an ester, this is the primary component. The COOH is the carboxylic acid, but instead of having the H there, we have another carbon group. Esterification is a reaction of a carboxylic acid and an alcohol in the presence of an acid catalyst and heat to produce an ester. Remember, this is what's making the ester. When that happens, the hydrogen from here and the OH group from here is producing water. So we have the OH group here and the hydrogen here coming together to make water, which is right here. Then this portion of the alcohol is getting attached to the carbon. So this is all from the alcohol here. While this portion was from the carboxylic acid. An example of esterification is the reaction of ethanoic acid and 1-propanol to produce the ester called propylethanoate. It's responsible for the smell of pears. So let's try to do one on our own. The reaction of propanoic acid and methanol. Prop tells us there's 3 carbons. 1, 2, 3. Oic acid tells me there's an O and an OH. It's reacting with methanol, which is C with an OH group on it. I got lazy and I decided not to do the hydrogens. You can if you want. And there'll be hydrogens all around here as well. Around here. So the OH here is going to attach itself to the hydrogen here. And this is happening with heat and an H plus catalyst, with an acid catalyst. So we're going to get H2O when we're done, along with the propanoic part, which becomes propanoate, and then the methyl part. I'm going to shorthand it. So here you go. Here's the propanoic acid, the OH and the H come together, so that oxygen and that carbon come together. So naming the solutions. What I usually do, just as a mnemonic device for me, I put a line between the O's so I can divide it up between the carboxylic acid and the alcohol portion. So the carboxylic acid is the part with the 2 lines. That's going to make the second part of the word. So how I remember this, and you can remember however you want, but I see 2 lines, that means it's going to be named second. This one will be named first, and that's the alcohol. The alcohol is named first, then the carboxylate will be named second. So if we go here, this part's named second, this part's named first. Ethyl, ethanoate. Draw the line. 1 carbon, so it's methyl. 3 carbons, propanoate. Draw the line. Ethyl, benzoate. So let's try this one. Draw the line. That becomes ethyl. And then propanoate. Remember, this part came from the alcohol. This part came from the carboxylic acid. Alright, so let's try this one. Draw a line. There's 3 carbons here, so that's propyl. 2 carbons is F, so ethanoate. This would be the common version, propyl acetate. Many of the fragrances and perfumes and flowers and the flavors of fruits are due to esters. Small esters are volatile, which means that they turn into a gas easily so we can smell them. And they also dissolve in water because of all the oxygen, so that way we can taste them. For instance, if we look at this, okay, let's do that activity again. 1, 2, 3, 4, 5. So that's pentyl. Ethanoate is in bananas. Let's do this one. 2 is ethyl. 4 is butanoate is pineapples. So let's draw some of these structures. Let's start off with 3-bromobutanoic acid just as a review. 1, 2, 3, 4. There's oic, which means I need OOH. 1, 2, 3 for bromo. Remember, the first carbon is always the one on the double bonded oxygen. Now, ethyl propanoate. So I know I have carbon double bonded oxygen with another oxygen. That's going to be an ethyl group. CH2, CH3. Prop means we need 3 carbons here. There's 1, 2, 3. So that's CH2 and CH3. And there you go. And that is how you name esters.